Well, we're talking about now trigonometry. This is good for grade 10. And the question says trigonometry ratio. Exercise 1, the question says redraw the triangles below and indicate which sides are opposite, adjacent, and hypotenuse with respect to theta, the angle. Okay. Now, all these sides here are named with respect to the angle theta, okay? So now when I look at, in this triangle, for instance, the angle theta is over here. Then the side opposite to the angle theta is called the opposite side. So this side is opposite, okay? Opposite side. Okay, and then this side here will be called adjacent side because it is adjacent to the angle theta. So this is adjacent side. Adjacent. And then this other side is at the longer side of the triangle. Okay, the longer side of the triangle is the right angle triangle is the hypotenuse. Okay, so this is hypotenuse. Hypotenuse is the longer side of the right angle triangle, and then it is opposite to the 90 degrees angle. Okay, so now in this triangle here, I look at where the angle theta is there, and then opposite the angle theta is this side. This side is opposite to the angle theta, so this is the opposite side. Okay, this time I'm just gonna say O. Okay, and then the side adjacent to theta is this side. Okay, which is I will say between the 90 and the theta. Okay, between the 90 and the theta, these two, this side adjacent side. So this is adjacent, so I just want to say A. And then the hypotenuse is the longer side, which is always opposite the 90 degrees angle. So this side is hypotenuse. Okay. Well, the question says that now we're doing question B. It says state the following in terms of G, K, and M. Okay. We have like these symbols, sine K, tan K, cos, etc. So those are called the trigonometric ratios. Okay, there are many, but we will learn basically about 3 trigonometric ratios. Okay, the formulas are like sine of the angle theta, okay, is given by the opposite side, okay, is the opposite side over the hypotenuse. Okay, that constant that you get from opposite side over hypotenuse is called the sine of the angle. And then cos of the angle theta is always equal to the adjacent side of the triangle over the hypotenuse. And then tan over theta is given by opposite side over adjacent side. Sometimes O here is called X, and then H is R. No, O is Y, and then H is R, and then A sometimes is called X, and then H is R still, and then therefore this will be like Y over X. Now let's answer the questions. Now when we say we're looking for sine of the angle by the point K, okay, so we're looking at this one, this ratio here, it will be the opposite side over the hypotenuse, which is M. So this will be, I'll say question 1, sine of K will be opposite side. The opposite side of K here is this K, and the hypotenuse is M. So this will be K over M, okay? Question 2 says cos of K. Cos now of K, cos of this angle, cos is adjacent over hypotenuse, okay? So I'll look at the adjacent side is G. If my angle is K, the adjacent side will be G, and then the hypotenuse will be M. So this will be G over M. 3, tan of K will be, tan is given by opposite side over adjacent. So if my angle is K here, opposite side is still K, the adjacent side is G. So this is going to be K over G. Okay. So now we can also do question 4. That's the sine of G. Sine of G. Then now my angle is no longer over here, but it is over there. Okay, that's the angle. So I can just put the symbol to say sine of G. Now, opposite side of the angle G here, because sine is opposite of hypotenuse. Okay, so the opposite side of the angle G here is G. Okay, and the hypotenuse is still M, the longer side of the triangle. So this is going to be G over M. That was 4, and then 5. Cos of G will be, cos is expressed by the adjacent over hypotenuse. Okay, so if G, the angle G is here, adjacent to G is the angle K. Okay, it is always in between the 90 degrees and the respected angle. Okay, in the question here, so it's between these two angles. So now it's gonna be K over, okay, adjacent side over hypotenuse, K over M. So it's gonna be K over M. Okay, and then 6 here, 10G, 10G, opposite, 10 is opposite over adjacent, opposite G is G, and the adjacent is K. So this will be G over K. Okay. Well, we have another question here, question C. The question says that state the following in terms of P, Q, and R. Okay. Now, as we did say that we have like we're going to discuss about the main 3 trigonometry ratio that we learned. They are sine of the angle, cos of the angle. So let me write it here: sine of the angle, cos of the angle, and then tan of the angle. Those are I can say the main 3 trigonometry ratios. So now they're given by, sine of the angle is given by the opposite side, okay, of the triangle, opposite side with respect to the angle over hypotenuse, and then cos of the angle theta is given by the adjacent side with respect to the angle always, okay, over hypotenuse, and then tan of the angle theta, which is given by the opposite side over adjacent side of the triangle. Now, I said that opposite side sometimes is called y. Okay, sometimes it's called y, so it's like y over, and then h sometimes is called r, so it's going to be like y over r. So is adjacent side is sometimes written as x, so it's going to be x over h, which is r, and therefore tangents of the angle will be over a will be sometimes written as y over x. Now, now let's answer the questions here that said the following in terms of P, Q, and R. Okay, number 1 here we have like sine of the angle theta. Now look at where theta is. Theta is here. Okay, theta is over here. Now sine of the angle is opposite over hypotenuse. So now look at the side which is opposite to this angle theta. It is this side. It's this side that's opposite to angle theta. So this is opposite to theta. So it's r. So I say here 1. Sine of theta will be equal to opposite, which is r, over hypotenuse is the longer side of the triangle, the side that is opposite the 90 degrees angle. So this one is q, so it's going to be r over q. And then question 2, it cos of theta. Cos of theta, and I look at where my angle theta is. Okay, cos is adjacent over hypotenuse. Okay, the adjacent side is always between the angle and the 90 degrees angle. Okay, it is adjacent to this angle here. So it's gonna be P over the hypotenuse, which is Q. So it's gonna be P over Q. Okay, and then tan of the angle theta is opposite over adjacent. So opposite is R and adjacent is P. So it's gonna be R over P. Okay. Then question 4 says like sine of alpha. Okay. What is sine of alpha? Alpha is this angle over here. And then opposite alpha, let me show. Angle alpha, opposite alpha is P. Okay. So I'm gonna say here P over hypotenuse, which is Q. So P over Q. 5. We have like they said what cos of alpha. I'm gonna write here. Cos of alpha is adjacent over hypotenuse. So now I'm gonna look at the side that is adjacent to alpha. Okay, adjacent side is always between the angle and the 90 degrees. So it's this side here R. So this side is called adjacent. See R over hypotenuse, which is Q. Okay, and then 6. The question says 10 of alpha. 10 of alpha is opposite over adjacent. Opposite is P and adjacent is Q. Thank you. We have another question here. The question says that the triangle DEF is shown with the dimensions. Now, question 1 says determine the length EF. Question 2 says write the value of sin theta, cos theta, and tan theta. Okay. Now, we said that first of all, they said, let's answer question 1. Determine the length of EF. EF is, when I look at the length EF here, it is the side that is opposite the 90 degrees angle. It is the longer side of the triangle. This is what you call the hypotenuse, okay? From grade 8 and 9, we learned the hypotenuse. And the hypotenuse of the triangle is given by, it's like h squared. Hypotenuse of the triangle is opposite side squared plus adjacent side squared, okay? And then sometimes written as r squared will be equal to x squared plus y squared. It's the same formula, okay? R is just h, and then r is h squared, and then x squared is o squared, y squared is, actually, y squared is o squared, but you know, in addition, you can reverse the order, doesn't matter. I can say a, let me just say a squared plus o squared. See the same thing, okay? I want just to follow alphabetical order here. A squared plus o squared. Then to find the hypotenuse here, I will say number 1, I will say EF here is my hypotenuse, okay? So EF squared will be equal to 10 squared, okay, plus 24 squared, okay? And then that makes EF squared equal to 10 squared is 100, okay? And then plus 24 squared is 576. So that makes EF squared to be equal to 676. Now, note that this is EF squared. I'm looking for EF, the side EF, not the square of it. So to get EF squared, what I can do, I will square root both sides. I must square root here, square root there. Why square root? Because the square roots will cancel the power of 2, and then I'm left with EF. This will be equal to 26. Okay, so EF will be 26 centimeters. Now, question 2 says write the value of sine theta. Okay, what do we know for sine theta? Sine theta is given by the opposite side, opposite over hypotenuse, or sometimes they write it like y over r. Okay, so sine theta in this case will be opposite side. If the angle theta is the opposite is 10, the opposite side of this triangle is 10, and then hypotenuse is the angle opposite the 90 degrees. Okay, we find this to be 26. So this will be 10 over 26. Okay, this can be simplified. This is equal to 5 over 13. Okay. We can also find cos theta. Okay, if the angle here, cos theta will be right here. Cos theta will be adjacent, okay, over hypotenuse, which is x over r. Adjacent side over hypotenuse. So that means cos theta will be adjacent to the angle is 24 and the hypotenuse is 26. So we can simplify that. We divide by 2 both sides, the fraction. So this is going to be like 12 over 13. Okay. And we also know that 10 of the angle 10 of the angle theta is given by opposites over adjacent, sometimes written as y over x. So that means 10 of theta here will be 10 over 24. So this means that's 10 of theta. If we reduce the fraction, okay, we divide by 2, it's going to be like 5 over 12. Okay, thank you. Well, we have another question here. The question E, that is question E. Now, let me just write it here, E. The question says that determine the value of sine n and tan c. Now, if I look here, I need to find the value of sine n. N is over here, this angle. We do know that sine of the angle is always opposite over hypotenuse, or y over r. So opposite side is this side, and then hypotenuse is there. But now when I look here, opposite side is not known. We don't know what the opposite side is. It's unknown. So how can I determine the value? So we can do that by using the Pythagorean theorem. Okay, that says that h squared equal to a squared plus o squared. Okay, so in this case, h squared, h is 17, so we're gonna say 17 squared. H is the hypotenuse. Okay, h 17 squared equal to a squared, which is 15. So I'm gonna say here 15 squared. Opposite is the side that I'm looking for because it is opposite to the angle n. I'll say here o squared. Now, 17 squared is equal to 289. So that makes 289 equal to 15 squared is equal to 225. 225 plus o squared. Okay, plus o squared. Now, if I move the 225 over, this will be like 289 minus 225 equal to o squared. Okay, move a little bit up there. And then 285 minus 225 equal to 64. and then I have O squared. Now to get the value of that, I need to square root both sides, okay? Square root there, and then of course this will give me plus minus 8, but you know, it's of course it's plus minus 8, okay? But you know, sides cannot be negative. That is why we will take only the positive values. We can say the opposite side here is equal to 8. Careful, it's not 0 equal to 8, but it's O equal 8, okay? Then we can continue solving our problem here. So we can say sine of the angle theta will be equal to 8, okay, over R, which is over H, which is 17. So sine of theta is 8 over 17, okay? Now, over here, question 2 says 10 of C. So now I look at C is this angle here. So 10 of C is given by opposite over adjacent, or y over x. So now, if I look at opposite side is this side. It is also unknown. We need to find it. How can we? Look here, we have like the two sides here are given, so we can still apply the Pythagorean theorem. So now here, the longer side is 5k. So I'm gonna say here 5k squared. 5k squared equal to adjacent, so it will be 4k squared plus opposite squared. Okay, so now 5k, careful, 5k squared is equal to 25k, right? No, it's 25k squared, and that's going to be 16k squared, because the power of 2 here is for everything within the bracket. It's 5k to the power of 2, 4k to the power of 2, plus O squared, okay? And then that's, if I move the 16k over, that will make what? 25k squared minus 16k squared equal to O squared. That makes what? O squared equal to 25k squared minus 16k squared. They're both expressed in terms of k, so we can just do 25 minus 16, which is equal to 9k squared. Now to get the value of O, we can just square root both sides, and then that makes O equal to, of course it is plus minus 3k squared, but the negative length doesn't make sense, so this is going to be like 3k. So therefore over here the value is 3k. Yeah, thank you. Well, we have now question F, says that determine cos of L and cos of B. Now let's see. Cos of L is here, cos of B is there. Now let's work it out. Cos of theta, that the formula is always equal to adjacent over hypotenuse, so sometimes equal to written as x over r. Okay, so now in this case, if I look at the angle L, this angle here, the adjacent side is this side, okay, and then the hypotenuse is there, so there is really no need for me to find this angle. I don't really need to find it because I have like all the solutions there. So so I can just say over here it will be adjacent side is 24 and hypotenuse is 30. I can write there, and then this can be simplified. Okay, if I divide both sides by 6, I'll get 4 over 5. Okay, that was question 1. Now for question 2, no, it's not done yet. Question 1 says also okay, let me write it this way. I should have precised that cos of L will be equal to 24 adjacent over hypotenuse 30, which means cos of L will be equal to 4 over, if I divide by 6, it's going to be 4 over 5. Now, I want to do cos of B. Cos of B. I look at B is over here, and then adjacent side, B is this angle. Adjacent side is this side between the angle and the 90 degrees angle. Okay. And then hypotenuse is unknown. So over here, we need to find the hypotenuse. Okay, we need to do that by the help of the Pythagoras theorem. So we know that h squared equal to a squared plus a squared plus o squared, or sometimes r squared equal to x squared plus y squared. Now, hypotenuse here is unknown, so I keep it like r squared will be equal to x squared, which is let's say it can be 12 or it can be 16, doesn't really matter. Or that doesn't really matter here. 12 squared plus 16 squared. And then 12 squared is like 144. And then 16 squared is 256. So adding the two, this is equal to 400. So now to solve this, we can just square root both sides. And then r equal to 20. So now this is equal to 20. Then we can work out. Okay, we can say 16 over 20. So we can say cos B will be equal to 16 over 20. 16 over 20 can be reduced, okay? If I divide both sides, the numerator and the denominator by 4, so now we like 4 over 5. Now, question 2, that was question 1. Question 2 says here, what do you notice? Okay, we notice that cos of this side and cos of L and cos of B are equal, okay? Say here, cos of L, okay, is equal to 4 over 5 is equal to cos of B. So cos of L and cos of B. So therefore, cos of L equals to cos of B. That's what you notice. Now the question says, what can you reduce? What can you deduce about the two triangle and why? Okay. Now, what can we deduce? When I look at here, this angle and that angle are equal. Okay. And then they both are a right angle triangle. And we can see that this triangle, clearly see that this triangle is twice this other triangle. Because over here, if I look at the adjacent side, I call this side adjacent because I look at the angle L. This side is between 90 degrees and the angle L. So this side is adjacent to L, is 24. And then adjacent to B and E is 16. And now, when I look at here, it's, I'll say that this side is 20, okay? And this side is 30 centimeters, and then this side is 12. So if we calculate this, we're gonna get, if I calculate this side, we're gonna get it to be 16. So basically, this bigger triangle is just 1.5 times this other triangle. So the two triangles are similar, okay, because they have the ratio of 3 to 2. If you don't see it yet, let me explain this other way. Or let's just say the fact that this angle and that angle are equal, and then they're both 90 degrees angles, we can say that the two triangles here are a similar triangle. Okay, I was also saying that the two triangles are in the ratio 2 to 3 because if I look at 12 to 24, not 12 to 24, but if I compare the similar, the corresponding sides, this is 24 and that's 16. Look here, 24 and 16. If I reduce this, I'll divide here by 4. and then this will be 24 by 4 is 6. No, not by 4, rather divide by 8. I mean, by 8, okay? It's gonna be, excuse me, I wanna write it this way instead. I wanna write 16 to 24, okay? So I'll divide here by 8, and then this is equal to 2 to 3. That's for the corresponding side, 24 and 16. Now let's take the other side. The other corresponding side, 30 and 20. Look here. If this side is 20 and the other is 30, I can divide both sides by the highest common factor, okay? So if I divide by 10, we still get here 2 to 3. And so also with this side, how much? I said 16. Let's double check. It's gonna be like square root of 30 squared minus 24 squared, and this is equal to 18. I meant, okay, sorry, that was 18. 18. If I compare this side and that side, it's gonna be the same thing. So it's gonna be like 12 to 18. Okay. If I reduce this, I divide by 6, and then this is still 2 to 3. Okay. So the corresponding sides are in ratio 2 to 3. So the two triangles here are similar. So this is the exact same triangle here, but in the bigger than that. Thank you.